All right, we have our review. Got our calculator if we need it. Cool. Let's do it. Circle equations. What are the center and the radius? So remember, the formula is x minus h squared plus y minus k squared equals r squared. So don't forget the lie is h and k, which means lie and lie about the positive negative sign. So instead of saying the center is 1, -7, it's a lie. -1, +7. Opposite. Opposite signs, right? And then this 25 is not r, that's r squared. So we need to square root, and you get the square root of 25 is 5. Very similar with number 2. Lie, lie. So negative is positive, positive is negative. Radius. Oops. So 8 times 8 is 64. That's my radius. And could you plot this on a graph? Let's see it. Graph the following. So the center is lie, lie. So +2, +3. And then square root of 16 equals 4. So 2, 3. The radius goes 4 up, 4 down, 4 right, 4 left. And you can sketch yourself a nice circle. Okay? Doesn't have to be that nice, just anyways. Lie, lie. Positive is really -4. Negative is +1. Square root of 9 is the radius, which is 3. So -4, +1. 3 means up 3, left 3, down 3, right 3, and then sketch yourself a nice circle. It's not perfect, but it'll do. All right. Vocab. Let's do this vocab. All right. Diameter all the way across through the center. So not OB, but A to C would be a diameter all the way across. Radius is halfway. It could be OA, OB, or OC. And you could also do CO, BO, AO, any combination of that. And I can see OB is a radius. That's letter I. Hi. The center is O, the dot O. So that's J. Chord. Okay, has to go from edge to edge. That could be AD or DA. That could be AC or CA, but usually we just call that a diameter. So let's look for AD or DA. Now look, this with the arrowheads, that's not a chord. It's a segment, so it has no arrowheads. Sorry, and that's going to be letter E, okay? Minor arc is less than half, so the only ones that have arcs are C and D. Okay, that's it. So minor is always 2 letters. Just by looking at these, it's got to be letter D. And let's take a look. DC is less than half a circle. Yeah, so letter D. Major arc has 3 letters. BAF, B to the A to the F is more than halfway. So yeah, that's letter C. Okay. Secant line goes through the circle, but it has arrowheads. AD, arrowheads. That's A. Okay. Point of tangency. The tangent line that touches it once is this line, BE, so it touches at the point B, so that's got to be my point of tangency. Letter F. Don't put letter B there, because that's something else. Tangent line, like I said, was BE with arrowheads, so that's G, BE with arrowheads. And then the central angle has to have O as the middle letter in the central angle. So it could be AOB, or BOA, BOC, or COB. Technically, it could be AOC, COA. That could technically also work, but let's look. COB, Cobb. That is central angle. Okay. Okay, problem. Radius of a circle is 5, so definitely label this R is 5. This R is 5. And then it makes a triangle where you have to add those up. So I'm going to redraw this triangle. Down here is B. Okay, this radius right here is 5. And then this piece is adding 5 and 8. 2 pieces. Okay, 5B and 3. So it's going to be 5 squared plus letter B, that's not a 6, B squared equals 13 squared. Now, hopefully you know that that's a Pythagorean triple, but if not, you can do the math. Sorry, it's 169. When you're missing a leg, you got to subtract. B squared equals 144, and then square root. Square root of 144 is 12. All right, 16 and 17. Round to the nearest tenth. So when you're doing this stuff, the formula is, the angle. Yeah, so it's the internal angle equals 1/2 arc plus arc. Okay, you might remember this. Oops. Plug in. Okay, so yeah, this formula. Okay, so let's go back to it. Oops. So on this one, interior angle x is going to equal 1/2, and these two arcs added together. Okay. Cool. So I don't have to do too much. Just plug it in. 1/2 to the right, 131 plus 52 gives me 91.5. Same thing over here. Internal angle intercepted by chords equals 1/2 intercepted arc plus intercepted arc. 93 and 76. $84.5. Cool. Too easy. All right, down here, solve for x. Goodness. Okay, so remember the inscribed is half of the arc. So this 2x plus 15, whatever's on the edge, equals 1/2 of whatever's intercepted on the arc, which here is 82. Half of 82 is 41. Subtract 15. 2x equals 26. Divided by 2, and you get x equals 13. All right, same thing here. Inscribed angle 75 equals 1/2. And then the intercepted arc is 29x plus 5. All right, there's a couple ways to do this. Instead of putting half of the inscribed angle, you could just multiply the instead of half of the intercepted arc, you could just do the inscribed angle times 2. So to get rid of a half, it's times 2. You get 150 equals 29x plus 5. Minus 5 gives you 145. And then divide by 29. What's 145 divided by 29? 5. So x equals 5. Okay. The inscribed equals half of the intercepted arc, or 2 times the inscribed equals the intercepted arc. Either way. Okay, what's the length of BD? So first we got to find x. So remember, part on the same chord, part times part equals the other chord, part times part. So 3.6 times x equals 2.7 times 6.4. What's 2.7 times 6.4? You get 17.28. And then you got to get rid of that coefficient by dividing by 3.6. And you get 4.8. Now that's just x. That's not the answer. Hello. X right here is 4.8. If you want BD, B to D, you got to add the two parts. So BD equals 3.6, the left part plus the new right part we just got. Okay. And I think you get 8.4. Yep. All right, down here. Now, the central angle is supposed to be congruent to, or whatever, the measurement of the central angle is equal to the measurement of the intercepted arc. Okay, so it says not just BC, it's AC all the way over here is 20x minus 11. So whenever you have a central angle, you just set it equal to whatever is the intercepted arc. And then you can solve it ye old-fashioned way. Okay, 136 divided by 20. Okay. 136 divided by 20. 6.8. Cool. All right, calculate for each value. Okay, JKL, J to the K to the L. Now look, JKL, if this reflex angle is 190, then JKL is also 190. It matches the central angle, okay? But JKL is not the shaded area. The shaded sector, to figure out this angle, I need to do 360 minus 190, and I'm going to get myself 170. So you got 170 degrees. So over here is 170 degrees. Okay, so what do I do? Theta over 360. Okay, and then for a shaded sector is pi r squared. So theta is 170 over 360 pi, and then the radius is 9, labeled here, 9 squared. 170 over 360 pi 9 squared. 170 over 360. I'm not going to type the pi because I'm going to put it in terms of pi. And then hit this little fraction button, 153 over 4 pi. Do not leave it as a decimal, or you can turn fractions into decimals to check your answers with the answers on where. Let's do this. Okay, find the length of the arc. Length of arc is arc length. Okay, so what is that? Theta over 360, 2 pi r. Okay, r is 12, so r equals 12. Theta equals 120. All right, it's too easy. 120 over 360, 2 pi 12. Okay, we're going to leave it in terms of pi. 120 over 316, 120 over 360, 2 pi. I'm not going to multiply the pi. I'm going to write the pi. 2 pi, 2 times 12. And I get 8. Since I didn't type the pi, I'm going to write pi as in my answer. Okay. And I got 8. 8 pi. Okay, last but not least, solve for the radius. This is working backwards, okay? because remember, it's theta over 360 2 pi r, okay? Okay, equals the arc length, right? So we know theta is 120, so 120 over 360 2 pi r, and it equals the arc length measured in millimeters, so it's going to be 8 pi over 3. Okay, so here's the deal. To get rid of this, okay, to get rid of this divided by 360, we need to do times 360. Okay, so this will be times 360. And then to get rid of the 120 times 2 times pi, 120 times 2 is 240, right? Pi. So if you divide by 240 pi, divided by 240 pi, that the only thing left is r. So that would be r equals. Okay. Now, this is going to be kind of weird, but we got this, okay? So 8 pi divided by 3 times 360 divided by 240 pi. Put in that ugly mess on the right, and it'll give you your radius of 4. And that is your review. Study this because it will be very similar to your test